Welcome back, ladies and gentlemen. We are going to finish up our first unit of study today. This will be the very last video that I'm going to ask you to watch in this unit, and it is over scientific notation. Now, scientific notation is the main way that we represent numbers in science that are either very, very large or very, very small. It's a pretty simple method to figure out how to write these and how to determine the numbers based off of scientific notation. So without further ado, let's go ahead and get started. Our objectives today: you should be able to correctly write numbers using scientific notation, and then you should also be able to perform some basic calculations using scientific notation. And again, our only vocabulary word is scientific notation. So, when we're talking about writing numbers in scientific notation, again, we're focusing on writing numbers that are either really large or really small. And numbers are written in a very specific form. The form is m times 10 to the nth power, okay? Where m is a number between 1 and 10, and n is a whole number. So if you look to the right here, 2.13 times 10 to the third is the same number as 2,130. 7.5 times 10 to the negative fourth is the same as 0.00075, and so on. So these numbers play a big role in representing different large or small numbers. You're going to see quite a bit of these in this chemistry class, so it's very important that you fully understand how to write these and how to use these in calculations. You'll also need to understand how to type these out in your calculator, and that's something that's very important for a lot of chemistry students, because I see a lot of students make mistakes not because they don't know how to do a problem, but because they don't understand how to use scientific notation on their calculator. So we'll address that maybe in a later video. So you'll get a question like this: convert the number 56,000 kilometers into scientific notation. So the first thing we need to do is to determine m, because remember, it's m times 10 to the nth power. So the first thing here is we determine m by moving the decimal point number to the left or right until the number is between 1 and 10. So if we look here, the decimal point is going to be located just past that last zero, 56,000 decimal point kilometers. So in order to get that number between 1 and 10, we have to move the decimal place to the left 4 times. If we move the decimal place over to the left 4 times, we get the number 5.6. Then the number n is determined by the number of places you moved the decimal point. If we go to the left, it's a positive number. If we go to the right, it's negative. So if we remember, in 56,000, we moved the decimal point to the left 4 spots. So to represent this number, we will write 5.6 times 10 to the 4th power. And then make sure you include your units at the very end. That's all you have to do. Move the decimal point to the left or the right until the number is between 1 and 10, and then count up the number of times you move the decimal point over. If it's to the left, you give it a positive number. If it's to the right, you give it a negative number. Simple enough. Now let's do some practice problems together. Write the following numbers using correct scientific notation. 34,800. So the decimal point is there. So we need to move it over 1, 2, 3, 4 times. Once we do that, the number is going to be 3.48. How many times did we move it? 1, 2, 3. We moved it 4 times. And since we moved it to the left, it's a positive value. So we just add our unit at the end. So 34,800 meters is represented in scientific notation as 3.48 times 10 to the 4th meters. Simple enough. Let's keep going. So here, we're going to move the decimal place to the right 1, 2, 3, 4 times. So that number now is 3.42 times 10. And we moved it over 4 times. If we move it to the right, it's a negative. So we got 3.42 times 10 to the negative 4th, and the unit is moles. Okay? Let's do the one down here at the bottom. 98.3 liters. Again, we need to move the decimal point to where the number is between 1 and 10. So we'll take that decimal point, we're going to move it over 1 spot. So our new number is 9.83 times 10. And we moved it to the left 1 spot, so that's a positive 1. And our unit is liters. Okay? That's how you write those numbers using scientific notation. Pretty straightforward. Just make sure you follow the rules accordingly. You guys will have no problems with this whatsoever. So let's say we're adding and subtracting numbers that are in scientific notation. How do we go about and do this? Well, the value of n, the exponent, has to be the same before we do any adding or subtracting of the numbers. So for example here, it asks you to add 6.1 times 10 to the 4th kilograms and 4.6 times 10 to the 3rd kilograms. Well, those exponents are not the same number. However, if we move the decimal place over 1 to the left, it's just like before. If we move to the left, we add a number. And if we move to the right, then we subtract a number. So the example here, if we move 4.6 times 10 to the 3rd kilograms, we move that decimal place over one spot to the left, then it becomes 0.46 times 10 to the positive 4. So if you move it to the left, you're going to add an exponent, and if you move the decimal place over to the right, you will lose an exponent. You do this until both numbers have the same exponents, and then you can just add them like you would any other set of numbers. So here we take 6.1 plus 0.46 and we get 6.56 times 10 to the 4th kilograms. But remember, we're adding numbers here, so we need to use significant figures. The first number there, 6.1, has one number beyond the decimal. 0.46 has two numbers beyond the decimal. So our answer should have one number beyond the decimal, which is why we get 6.6 times 10 to the 4th kilograms with significant figures. All right? When multiplying or dividing, the exponents are added or subtracted respectively. So let's say we divide 4.55 times 10 to the 5th by 3.22 times 10 to the 3rd. You'll do the exact same thing you would do normally if you were dividing two numbers. So 4.55 divided by 3.22 is going to give you 1.41. Now to determine the exponent, because we are dividing, you are going to subtract 5 from 3. So times 10 to the 5th is going to be subtracted by times 10 to the 3rd. 5 minus 3 is 2. So your exponent on your answer is 2. Simple enough. So when we divide those numbers and then subtract the exponents. So as you can see here, 4.55 times 10 to the 5th divided by 3.22 times 10 to the 3rd is 1.41 times 10 to the 2nd using correct significant figures. Also keep in mind that if the number at the end is not between 1 and 10, you need to adjust the exponent and number accordingly. So we may need to move the decimal place over one spot to the left or one spot to the right in order to get it in correct scientific notation, because keep in mind that whole number has to still remain between 1 and 10. So now let's do some practice problems together. Alright, so let's do some of these practice problems together. We've got 3.56 times 10 to the 3rd kilograms plus 1.23 times 10 to the 4th. Now if you remember the rule, we have to make sure that the exponents are the same before we add them. Well, here we have a 3 and here we have a 4. So in order to do this, we can either move this decimal point to the right one, which will give us times 10 to the 3rd, or move this decimal point to the left, which will give us times 10 to the 4th. I'm going to move this over to the left, because I think that's going to make things a little bit easier. So when I add these two numbers, it's now going to be 0.356 times 10 to the 4th. Keep in mind where I got that number from. And then I'm going to add 1.23 times 10 to the 4th. And I just add those two numbers together. So what I get is times 10 to the 4th, and then I'm going to get 1. I do a little bit of mental math here. 1.586 times 10 to the 4th. Now remember, we have to do correct significant figures here. I have 3 numbers beyond the decimal point and 2 numbers beyond the decimal point. So my answer should be 2 numbers beyond the decimal point. So I round up. So it's going to be 1.59 times 10 to the 4th. And my unit is kilograms. And there's my answer. 1.59 times 10 to the 4th kilograms. Simple enough. Let's go to the next one. 9.65 times 10 to the 4th moles divided by 3.23 times 10 to the negative 2nd liters. Well, with this one, because we're dividing, we can just divide the numbers normally. So I'm going to punch those into my calculator now. The number I get when I divide 9.65 by 3.23 is 2.9 9 with significant figures. Remember, we'll have to have 3. Remember, we're going to be times 10 to the power of. Now remember, we've got our exponents here, and when we divide, we subtract them. So we're going to take 4 minus negative 2. Remember, 4 minus negative 2, we add the opposite. So the answer is going to be to the power of 6. Moles divided by liters is then our unit. So there you go. Simple enough, right? Just need to do a little bit of math here. So we just divided our two numbers. We divided this number by that number. And then we subtracted our exponents and plugged that in and get our answer. So again, pretty straightforward stuff. But as always, we'll have some more practice problems later on in class. So long story short, when we talk about scientific notation, the numbers are written in the form of m times 10 to the power of n, where m is a number between 1 and 10 and n is a whole number. The value of n must be the same before adding or subtracting numbers, and when multiplying or dividing, the exponents are added or subtracted respectively. Just make sure you remember those key rules and you'll have no problem with any form of scientific notation in this class. So hopefully now you have a better understanding of how to correctly write numbers using scientific notation and to be able to perform those calculations. Thanks for listening, guys. This is the last one of this unit. We're going to start Unit 2 here shortly, so hope you have a great day, and we'll talk to you later.